Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. In today's video, I am going to explain about particle physics. In that, we are going to study about the classification of elementary particles. Especially in the KCET examination, the question is asked from this only. That is the classification of the elementary particles. Based on spin, elementary particles are classified into two main types, that is nothing but bosons and fermions. Under bosons, we have again it is classified into two types. It is massless bosons and the mesons. Under massless bosons, we have photon and the graviton. Okay. Under meson, it is subclassified into three types, that is eta meson, Keon meson, or you can call it as K meson, and pi meson. Yes, you people got no? Yeah. The photon, this is nothing but the elementary particle during electromagnetic reaction. The rest mass of this photon is 0 and the spin of this photon is plus 1. The spin is important, that's why I'm writing the spin of the photon to be plus 1. What does this graviton means? The exchange particle in gravitational force is nothing but my graviton, and the rest mass of graviton is 0 and it has the spin to be 2. Yes. Now, based on the spins, the elementary particles I told it is divided into two, that is bosons and the fermions. Let us study about the fermions now. Yes, in the fermions, we have again two types. Those are leptons and baryons. Yes, what are these leptons? Leptons are nothing but electron, muon, and tyon. These are the particles. We have electrons, muons, and tyon. We have the antiparticles also. That is, we have the neutron. Before the antiparticles, we have the neutrino of electron and neutrino of muon and neutrino of tyon. Yes, yes, you people got right. That is neutrino of a electron, neutrino of a tyon, and the neutrino of a muon. These we have the six particles under leptons. How many particles we have? We have six particles under leptons, and we have a baryons. Next, one more type of the fermions are nothing but the baryons. Baryons are divided into two types called as nucleons and eprons. Under nucleons, again it is divided into two types called neutron and proton. That is neutron particle and the proton particle. It is represented by the symbol N and it is familiar to us, and the proton is P. Yes. And eprons, we are not familiar. Eprons, under eprons we have a four particles, that is sigma, lambda, sigma, cascade, and omega. We have how many particles? Four particles, that is sigma, lambda, cascade, and omega. Yes, everyone got to know how the fermions are divided. Yes, yeah. Now, just now we studied about the leptons, right? A leptons, again it has the antiparticle. Every particle here will be having the antiparticles, right? So under leptons we have a six particles. So the six particles will be having six antiparticles. Electron will be having antiparticle, that is electron positive, that is we call it as a positron. Like that, muon will be having muon positive will be antiparticle. Tyon negative will be having tyon positive to be the antiparticle. Yes. Neutrino electron, it will be antineutrino of electron. Neutrino tyon, it will be anti-neutrino of tyon. Next, neutrino, we have one more type, that is neutrino of muon will be the antineutrino of muon, right? Yes, we have a 6 antiparticles. Yes, we will be now we got a brief idea about how the elementary particles are classified based on the spin, right? Yes. Now, very important concept. Under this concept only, the question arises. Yes, that is, we need to see the pictorial representation of how the particles is situated in this octet and what will be its charge we are familiar, and what is the spin, what is this isospin, and what is this third component of the isospin, and we will be studying about the strange number, everything we will be studying. Why we are going to study this means, the question is asked, you will get to know when I solve the questions. The question is asked, they will be given one question. Under that question they will be saying, they will be asked you people that verify whether this reaction is allowed or not. So if the reaction want to allow means these should follow some of the conservation laws. That conservation laws are nothing but that the charge should be conserved, the baryon number should be conserved, the lepton number should be conserved, and we have the isospin to be conserved, and third component of the isospin to be conserved, and strangeness to be conserved. For that, this meson octet structure will be very helpful for finding the conservation or finding the reaction is allowed or not. See, we have 6 particles at the corners of this octet structure, and 2 more particles will be inside. We have They are saying it is clearly the meson octet too. Based on the spin, uh, bosons are classified into 2 particles, that is massless and the meson, right? Under meson we have three particles, that is eta meson, k meson, and pi meson. Under k meson we have 4 particles, that is k positive meson and k positive 0, k negative, and k negative 0. These are the 4 particles under k mesons. And pi meson, it is pi 0, 3 particles, pi 0, pi negative, and it will be pi positive. So these particles we are going to draw in meson octet structure. Yes, yeah, everyone are getting my points. So how will be the structure? I am going to write one by one. Here it will be k positive 0, and here it will be k positive, and in the next line it will be pi negative and pi 0 and pi positive. This is completely the meson octet. So only the k particle and the pi particle eta 0 will come into the existence. Here it is k negative, and here it will be k negative 0, and we have one more particle called as eta 0. So these particles are situated like this in meson octet structure. Yeah, everyone got no. And now we are going to find what will be the isospin of these particles. We shall make the columns isospin. What will be the isospin? We shall see one by one. The isospin of these 2 particles, it will be half, that is, it is represented by the symbol I, it will be half. And isospin of pi 0, eta 0, pi negative, and pi positive, the isospin will be 1. And the k negative 0, for this the isospin will be equal to half. So I want to tell what is this isospin. We have the spin. The spin we can find. Spin is nothing but the angular momentum quantum number, right? We can find the spin using the formula 2I plus 1. And what are these bosons? What are these bosons? Under bosons only, no, we have a meson. The bosons are nothing but which is having the spin to be 0, 1, 2. right? It is the integral multiple, not the half integral multiples. Whereas fermions are the half integral multiples, like the spin, it will be having half 3 by 2 and 5 by 2. This bosons will be having the spin 0, 1 and 2. So if my this isospin is half means, it will be having the 2 spin number, no, it will be having the spin to be 2, means uh k positive 0 and k positive, so the isospin will be half. Pi 0, pi positive and pi negative, we have a 3 particles. If I substitute the I value to be equal to, that is isospin value to be equal to 1, it will be 3. You people are getting my words? Yes. Next, again the same thing, k negative and k negative 0, the isospin will be half. Now we have the third component of the isospin. There is a trick to remember that this third component of the isospin. How it does means, the corner to your left corner, it will be, if we have a isospin to be half means the third component of the isospin, I am changing the color and writing, it will be minus half. Here it will be, third component will be minus half, here it will be plus half, here it will be minus 1, here it will be plus 1, and here it will be minus half again, here it will be plus half. Whichever I am using in a light blue color, or you can call it as a light blue color, I am writing in a light blue color, that is nothing but the third component of the isospin, that is I3. The third component of the isospin I3. Yes, you people got. Next, we shall be moving to this strange number. What is this strange number or strange quantum number, or nothing but? These are nothing but again the quantum numbers. It is just the property of the particle. Okay, where we define the strangeness. Okay, the strangeness is represented by the, I'm changing the pen again. The strangeness is represented by the symbol capital S. So the strange of this k positive 0, k positive particle will be 1. Okay. Next, pi 0, eta 0 and pi 0, pi positive particle, pi negative particle, it will be 0. And the strangeness of k negative and k negative 0, it is minus 1. Okay. Yes, I must to tell the eta 0 and the pi 0, the isospin of these two will be 0. Okay, that is I3 of eta 0 and pi 0 is again 0. Okay, next we have the charge. We can find out easily from here. So these two particles will be having, charges is represented by the capital Q. It will be having plus 1. Yes, positive and positive. The charge is plus 1. K positive 0, eta 0, pi 0 and k negative 0. The charges, it is subscript, superscript, it is having 0. So the charge is nothing but 0. And yeah, pi negative, k negative, it is clearly known that the charge is equal to minus 1, that is q, which is equal to minus 1. Yes, I hope everyone got this Meson octet structure. I hope everyone got clear picture of this. Next, we will be moving on to second structure called Baryon octet. Likewise only we will be doing here for with it for Meson octet. Now we will be doing for Baryon octet. Under baryons, what we have nucleons and eprons, right? We have, under eprons we have what let us go to the chart. We have the eprons. Under eprons we have lambda, sigma, cascade and omega, right? See, this lambda is again uh, uh, it is considered to be lambda not particle, and cascade is divided into two particles called as cascade negative and cascade 0. Yes, and sigma is divided into three particles called sigma 0, sigma negative and sigma positive. Yes, and omega, it is omega to the power of minus 1. Okay, this is the classification under the particles itself. Okay, so we will be drawing this, the nucleons and the prons together in baryon octate structure. So we shall see how the structure will look like. We have uh, 6 particles on the edges and 2 more particles inside, same as the meson octate structure. So we have a neutron to your left and a proton, and here it is sigma negative, sigma 0 and here sigma positive, and we have cascade negative and cascade positive, right? And here it will be lambda 0. Now we know that the how to find the isospin of neutron and proton. You can guess and you can tell the isospin of neutron and proton is half the isospin of sigma 0, sigma negative and the sigma positive, it is 1, and the isospin of cascade negative and the cascade positive, it is half. And the third component of the isospin, I am changing the color to light blue. Yes, so it will be look here, it will be minus half, right? And here it will be for proton, it is plus half. For sigma negative, it is minus 1. Here it will be plus 1, and here we have a cascade negative to be minus half, and cascade positive, it will be plus half. You got right. And for lambda 0 and sigma 0, the isospin, the third component of the isospin is 0, whereas the mm, one more important point you need to observe here is the isospin of lambda is 0, whereas for cascade it is 1. Okay, the lambda, it is the lambda naught, the isospin for I'll write here the lambda naught, it is 0 only. For summation, that is sigma 0, it is not summation, it is sigma 0, it is 1. Yes, I hope everyone clear. Yes, this is the important point that I want to tell. Yeah, now we will be moving on to the strange number. Yes, the strange number is nothing but the quantum number. It is a strange quantum number. It is the property. We shall see what will be the strange number. For neutron and the proton, the strange number is 0. And for sigma 0, sigma positive and sigma negative and lambda 0, the strange number, it will be minus 1, means it will be going on reducing. So here it will be cascade negative and cascade positive, it is minus 2. Yes, I hope everyone it is clear. Next we have the charge. Proton, it is positive, right? And it is sigma positive, so charge which is equal to plus 1. And neutron, it is a neutron, means it is neutral. We have no, and we have studied in our previous classes also, that is in our lower classes. So it is charge, it is equal to 0. Then sigma negative and cascade negative, so the charge which is equal to minus 1. I hope that baryon octet is clear to you people. And now we will be moving on to baryon decuplet. Yes, baryon decuplet, one more the baryons we have, that is omega negative, that is omega minus 1, that will come into the existence. Here we have 1, 2, 3, 4 particles in the first row, and we have 3 more particles in the second row, and we have 2 particles in the third. Finally we have 4, so it will be 3 3 uh, 10 particles. So it is for baryon decuplet, we have instead of lambda we have delta minus 1, and here it will be delta 0, and here it will be delta positive, and here it will be delta positive positive. Yes, and in the next row we have sigma star 0. It is similar to sigma, sorry, it is sigma star negative. I am going to correct this. It is sigma star negative. Yes, one second. Sigma star negative, and here it is sigma star 0, and here it is sigma positive, and here we have a cascade star negative, and here we have a cascade positive, that is cascade 0, sorry, and finally we have omega to the power of minus 1. This is the structure of a baryon decuplet. Here the third component, the isospin, will be isospin. So here it is four particles. No, it will be 3 by 2. The isospin will be 3 by 2, and the isospin for sigma negative, sigma 0, and sigma positive, it is same. I showed in the previous slide, it is 1. For cascade negative and cascade 0, it is isospin to be half, and omega to the power of minus 1, the isospin is 0. Next, the third component of the isospin I am showing in light blue color. You can see here it is minus 3 by 2 for delta to the power of minus 1. Here it is minus 1 by 2 for delta to the power of 0, and delta plus positive it is half, and delta positive positive it will be 3 by 2. Cascade negative it is minus 1, cascade 0 it is sigma 0 it is 0, sigma positive it is plus 1. I'm seeing again it is cascade. No, it is the sigmas. Sigma negative, it is minus 1, sigma 0, it is 0, sigma positive, it is plus 1. This, the symbol is called cascade. It is minus half, here it is plus half, yeah, and omega minus 1, it is 0. The third component of the isospin is 0. The strangeness for these first particles for delta, it is 0, then it goes on reducing. That is, the strangeness is which is equal to 0, then it will be minus 1, and then it will be minus 2. Finally, it is minus 3. I hope everyone clear is. We till now we have studied about the meson octet and baryon decuplet and the baryon octet. This is decuplet and this is the octet structure. Yeah, everyone, I hope everyone is clear. Now we will be moving on to the final concept of this session, that is conservative loss. Why we studied all this till now means to check whether our given reaction is a strong interaction, or it is electromagnetic, or it is weak interaction. To know about the strong, weak, and uh, what electromagnetic, it should allow the equations. No, first the reaction to be allowed, or else if the reaction is itself not allowed, means it does not participate in either strong or electromagnetic or weak interaction. Let us see, when I say the interaction to be strong, when I say the interaction to be electromagnetic, when I say the interaction to be weak. Yes, we shall see one by one everything. Yes, when I say it to be the strong interaction, when the isospin is conserved and the third component of the isospin is conserved, as well as the strange quantum number is also conserved. When all three are conserved, that time I can say it is a strong interaction. When I say it is the electromagnetic interaction, when the third component is conserved and even the strange number is also conserved, but the isospin is not conserved, at that time I can say the given reaction is my electromagnetic interaction. Yes, next we have a weak interaction. In weak interaction means Even the isospin is not conserved, and the third component of the isospin is not conserved, and even the strange number is also not conserved, that it can take the values either 0 or it can take plus or minus 1. If I get my strange number, that is delta is to be equal to plus or minus 2 or plus or minus 3, at that time I can say the reaction is itself not allowed. The reaction is itself not allowed. Yes. Yeah, I hope everyone got my point. Yes. Next, we have a one more important point for antiparticles. Like I said, the electron negative it is a particle and electron positive it is an antiparticle. For antiparticles, for antiparticles, the charge, that is the Q. It is very important point, the charge, that is Q, and we have the third component of the isospin and the baryon number and the lepton number and the strangeness. Everything changes. Okay, these all the properties will changes for antiparticle. Okay, for electron, if we say it has a charge -1, for electron positive it is +1, like that. For third component of the isospin we shall see. And very important point, see this leptons do not participate in the strong interaction. These leptons do not participate in the strong interaction, that is very important. And the baryons and the mesons, they do participate in the strong interaction, that is meson eta 0, um, k negative and pi, everything they will participate. And in the baryons, the nucleons and the iprons, that is lambda, cascade, sigma, omega, they do participate in the interaction. Yes, if it is a lepton means this should follow the conservation of the lepton number. So for leptons we say the lepton number to be 1. For baryons we say the baryon number to be 1. Here the lepton number will be 0. Here the baryon number will be 0. Yes. Separately they should conserve the lepton number. Here the separately they should conserve the baryon number in the given interaction. In the given reaction. One example we shall take. Okay. So we have very first example. What they have given the reaction. The reaction I'm going to read now. It is pi negative plus proton and gives rise to sigma positive plus k negative, right? First we shall see what the question means, whether the reaction is allowed or not, whether the reaction is allowed or not. This is our question. First we shall see the conservation of the charge. So q, the charge which is equal to, it is pi negative, it is -1, proton means +1, so it will be +1 and -1, so it is 0. So delta q, it is 0, so charge is conserved. Next we have the baryon numbers. Why I'm taking the baryon numbers means here we have a proton and sigma, these two belongs to baryons, no? So pi negative, this is a meson, so the baryon number will be 0. So proton it is +1, and if we have the baryon means it is +1, k negative it is a meson, Keon meson, so the baryon number is also conserved, so it is 0. Next what we have the isospin. Isospin means pi negative. For pi negative the isospin is, let us go to the diagram, that's why these are very important. So pi negative isospin is 1, the third component of the isospin is -1, right? So the isospin is here 1. You can cross check the diagram and you can write it. So it is 1 and the third component it is -1. So the for proton the isospin is half, and for cascade positive the isospin is 1, and for sigma positive again I am saying it is cascade, no, it is sigma positive, it is positive 1, and k negative it is half. You can cross check in the diagram if you have a doubt. And very important point, the isospin is not added normally, the isospin is added vectorially. Okay, the isospin is added vectorially. This is the important point that I want to convey you people, that is, it can add like this 1 plus half, or you can or add it as 1 minus half, like this. So 1 plus half is 3 by 2, or 1 minus half is half. So both the side it is correct only. So isospin is verified. Third component of the isospin we shall see now. So it is minus 1 for proton, it is plus half. For sigma positive it is half only, for k negative it is minus half, right? So whereas the isospin, leaving this everything is added normally only. So the third component of the isospin is added under the normal addition. Here it will be minus half, here it will be uh, here it will be half, here it will be half, no. So the third component of the, here minus 1 plus half, it will be minus 1 plus half, it will be minus half, no. And 1 minus half, it will be half. So the third component of the isospin, it is not conserved. So now we will be moving on to the strange number. The strangeness of pi negative, it is 0. You can cross check in the given diagrams that I have explained you. For proton it is 0 again. For sigma positive it is minus 1, and k negative also it is minus 1. So we are getting the delta s to be what? Minus 2. I told in the last slide itself, if my strange number is plus or minus 2 or plus or minus 3, I can say at that time the reaction is itself not allowed. So I can conclude that the given reaction is not allowed. Yes. For today, this much I want to explain. I have explained. I hope everyone understood. We will be solving more examples, that is previous year question papers, in the next coming video. Thank you so much.